Look up at the night sky on a clear evening, and you will see a massive, glowing gray sphere hanging in the dark ocean of space, roughly 238,000 miles away from your bedroom window. For thousands of years, humans looked at the moon with awe, writing poems, building mythologies, and dreaming about walking across its mysterious, dusty surface. Then, in 1969, 12 brave astronauts actually stepped onto the lunar dust, planted flags, collected rocks, and hit golf balls into the black sky. But after a few short visits, humanity suddenly stopped going. We packed up our bags, left our footprints behind, and retreated back to the comfort of Earth for over 50 long years. But that long silence is officially over. Right now, the world's most powerful space agencies and private megacorporations are engaged in a fierce, multi-billion-dollar race not just to visit the moon again, but to build permanent, self-sustaining human colonies on its barren surface. Welcome back to Cosmic Clueless. Today, we are packing our space bags, strapping on oxygen tanks, and sending our unluckiest Stickman proxy to live on the moon to figure out, what does it actually take to survive on our nearest celestial neighbor? How will future moon bases operate? And why is this desolate dust ball worth trillions of dollars? Before our Stickman starts picking out modern furniture for his fancy lunar apartment, he needs to understand that the moon is one of the most brutal, unforgiving, and hostile environments in the entire solar system. On Earth, we are spoiled by a thick, comfortable blanket of atmosphere that blocks deadly solar radiation, burns up incoming meteors, and keeps our air temperature nice and pleasant. The moon, however, has virtually no atmosphere at all. It exists in a permanent, harsh vacuum of open space. Because there is no atmosphere to trap heat or spread warm air around, temperature swings on the moon are completely insane. During the lunar day, which lasts for 2 whole Earth weeks, the scorching sunlight heats the dirt up to a boiling 250 degrees Fahrenheit. But as soon as the sun sets, the temperature plunges instantly into a bone-chilling minus 290 degrees Fahrenheit. That is a mind-boggling temperature jump of over 500 degrees every single lunar cycle. Picture our clueless Stickman proxy stepping out of his landing pod, wearing a standard winter jacket and a pair of fuzzy earmuffs, thinking he is just going on a cozy snow hike. Within half a second of stepping into the sunlight, his coffee cup instantly boils into steam, his boots melt onto the scalding rocks, and as soon as he steps into a shadow, he freezes solid into a human ice cube. His Stickman legs shatter into tiny glass-like pieces as he wobbles over a rock, sending him tumbling down a crater, while his emergency suit alarm blares at maximum volume. Classic Stickman preparation. But wild temperature swings are only the beginning of our Stickman's troubles. Without a global magnetic field or atmosphere to shield the surface, the moon is constantly bombarded by dangerous space hazards that would make Earth life impossible. First, there is galactic cosmic radiation and solar flares. A human standing unprotected on the moon's surface receives high doses of invisible ionizing radiation capable of damaging cellular DNA in a matter of days. Second, there is a continuous shower of micrometeorites. On Earth, tiny space pebbles burn up harmlessly as shooting stars. On the moon, these razor-sharp dust grains slam directly into the dirt at 40,000 miles per hour. If a tiny micrometeorite the size of a sand grain strikes a standard astronaut suit, it punches right through it like a high-speed sniper bullet. And then, there is the most sneaky, irritating, and dangerous threat on the entire moon: lunar regolith. To most people, lunar dust looks like soft, fluffy, gray sand on a sunny beach. But in reality, lunar dust is a microscopic nightmare. Because there is no wind or liquid water on the moon to erode sharp edges over billions of years, every single speck of lunar dust is a sharp, jagged piece of crushed glass and silica. Even worse, constant solar radiation charges these tiny particles with static electricity, causing them to cling stubbornly to everything they touch. During the Apollo missions, astronauts reported that lunar dust destroyed suit zippers, wore down thick layers of Kevlar boots, clogged vacuum seals, and smelled like burnt gunpowder. When our stickman crawls back into his habitat after his icy fall, he tries to brush the gray dust off his spacesuit, but the static dust sticks like superglue. He inhales a tiny cloud of static dust particles, triggering a massive, violent sneeze that inflates his space helmet like a balloon, blasting him backward through his habitat airlock and sending him rolling right back into the dark crater outside. So, if the moon is a radiation-soaked, vacuum-sealed furnace covered in sharp glass dust, how on earth are scientists planning to build permanent human cities there? Let us move on to part 2 and look at the mind-blowing engineering of real lunar habitats. If shipping a single pound of cargo from Earth to the moon costs thousands of dollars, human engineers cannot simply pack thousands of heavy concrete bricks, steel beams, and glass windows onto rockets and fly them across space. To build a permanent civilization on the moon, we have to learn to live off the land, a concept space scientists call in situ resource utilization, or ISRU. Instead of bringing materials from Earth, future lunar pioneers will use autonomous 3D printing robots to harvest the razor-sharp moon dust and melt it into ultra-strong, solid ceramic structures using high-powered solar lasers. Imagine automated rover printers zipping across the craters, scooping up lunar soil, and baking thick protective shell domes directly over inflatable habitat modules. These thick ceramic walls will act as a natural shield, blocking lethal space radiation, absorbing extreme temperature swings, and stopping high-speed micrometeorites in their tracks. Now, picture our Stickman proxy trying to operate one of these high-tech solar 3D printers. He turns the laser intensity knob all the way up to maximum, trying to speed up the construction of his new lunar penthouse. But the supercharged laser beam reflects off a shiny metallic rock, bounces off his helmet visor, and accidentally carves a massive hole straight through his inflatable living quarters. All the internal air pressure rushes out with a deafening whoosh. The decompression sucks our stickman out through the tiny hole like toothpaste squeezed from a tube, launching him into low lunar orbit at top speed. Classic stickman architectural design. But what if building heavy domes on the surface is way too dangerous and complicated? What if nature already carved out ready-to-use underground cities for us billions of years ago? Welcome to the world of lunar lava tubes. Billions of years ago, when the moon was still geologically active and covered in raging volcanoes, massive underground rivers of glowing liquid basalt carved out colossal hollow tunnels beneath the gray surface. When the lava drained away and cooled, it left behind giant, structurally sound underground caves stretching for dozens of miles. Some of these lava tubes are over a mile wide and hundreds of feet deep, large enough to swallow an entire modern Earth metropolis, like New York or Tokyo. Living inside a lunar lava tube is the ultimate survival hack. Deep underground, the fixed ceiling of solid basalt rock completely insulates human habitats from cosmic rays, hides colonies from falling micrometeorites, and maintains a stable, comfortable temperature of roughly -20 degrees Celsius year-round. Scientists can simply drop inflatable habitats down into these natural tunnels, turn on the lights, and build entire underground cities protected from the harsh cosmic wilderness above. Naturally, our Stickman proxy decides to explore one of these deep lunar caves to set up his campsite. He straps on a pair of headlamps, drops a long rope down a dark, cavernous sinkhole, and rappels into the black void. But halfway down the cliff, he forgets that gravity on the moon is only 1/6 as strong as Earth's. He pushes off the rock wall for a small jump, but the weak lunar gravity launches him upward into the ceiling. He smashes his head against a sharp, jagged stalactite, breaks his flashlight, loses his grip on the rope, and tumbles hundreds of feet down into the dark abyss, landing flat on a pile of frozen space rocks in complete darkness. But wait, why were those rocks frozen down in the dark cavern? That brings us to the single most valuable resource in the entire modern space race: lunar water ice. For decades, scientists believed the moon was completely dry, like an ancient cosmic desert. But satellite radar data and deep space probes recently confirmed a Earth-shattering discovery. Deep at the lunar South Pole, inside permanently shadowed craters where the sun has not shone for over 2 billion years, lie billions of tons of pure, frozen water ice. Water is not just for thirsty astronauts to drink or wash their faces. By running electricity through water molecules, a process known as electrolysis, scientists can split water into pure hydrogen and oxygen. Oxygen provides breathable air for life support systems inside habitats, while combining liquid hydrogen and oxygen creates the most powerful liquid rocket propellant known to science. This means the Moon's South Pole will become the ultimate cosmic gas station. Spaceships will no longer have to carry heavy fuel all the way from Earth to travel to deep space. They can land on the Moon, refuel their tanks with lunar water ice, and launch out toward Mars and the outer solar system at a fraction of the cost. Has our Stickman finally found a way to strike it rich on the Moon? Or is his water mining expedition about to turn into a frozen catastrophe? Finding liquid oxygen and water ice at the lunar South Pole is already enough to spark a global space rush. But there is another hidden treasure buried inside the dusty lunar soil that could completely transform energy production on Earth forever. Helium-3. Helium-3 is a rare, non-radioactive isotope of helium that is constantly emitted by the sun in massive solar winds. On Earth, our thick atmosphere and strong magnetic field block helium-3 from ever reaching the ground, making it insanely scarce and absurdly expensive, costing over $40,000 per single gram. But the Moon has been soaking up solar wind for over 4 billion years. As a result, millions of tons of helium-3 are trapped right inside the upper layers of lunar regolith. Why is this tiny isotope worth trillions of dollars? Because helium-3 is the ultimate fuel for nuclear fusion reactors. Unlike current nuclear fission reactors that use uranium and produce dangerous, long-lasting radioactive waste, fusing helium-3 with deuterium generates massive amounts of clean, safe energy with zero radioactive leftovers. Scientists estimate that just 2 space shuttle loads, roughly 40 tons of helium-3, could supply the entire electrical power needs of the United States for an entire year. Naturally, our Stickman proxy decides he wants a piece of this multi-trillion-dollar energy pie. He straps a high-powered heating unit to his lunar rover, drives into the dusty plains, and begins heating tons of moon dirt to over 600 degrees Celsius to bake out the precious helium-3 gas. He collects a giant pressurized balloon full of purified helium-3. But our Stickman forgets basic high school physics. In the weak 1/6 gravity of the Moon, the super-light helium gas expands at a terrifying speed inside his collection tank. The gas pressure turns his collection balloon into a massive, vibrating bomb. Before he can press the emergency release valve, the balloon ruptures with violent force, launching our Stickman upside down across the crater like an untied party balloon, spinning him through the black sky until he lands flat on his back, right next to an American flag left behind in 1969. Classic Stickman energy mining. Despite the extreme hazards, the race to settle the Moon is happening faster than most people realize. NASA's Artemis program, alongside international partners and private companies like SpaceX and Blue Origin, is already building the Gateway, a permanent space station in lunar orbit that will serve as a staging ground for regular surface landings. Within our lifetimes, we will see permanent scientific habitats at the lunar South Pole, automated mining stations extracting water and helium-3, and human astronauts sleeping inside massive protected lava tube cities. Living on the Moon will not be a cozy tropical vacation. It will be a tough, dangerous frontier existence defined by low gravity, sharp glass dust, radiation shielding, and constant equipment checks. But settling our nearest cosmic neighbor is the mandatory first step for human civilization. If we can master building cities on the barren gray dust of the Moon, we can take those exact same technologies and apply them to Mars, the asteroids, and the moons of Jupiter. What about you? Would you volunteer to spend 6 months living inside a dark underground lunar cave just to see Earth floating in the sky above your head? Or would you stay comfortably on Earth, where the air doesn't boil your coffee? Drop your thoughts in the comments below. If you enjoyed this dive into future moon bases, wild space hazards, and Stickman helium explosions, smash that like button, subscribe to Cosmic Clueless, and hit the notification bell. Watch the skies, protect your spacesuit zipper from static dust, and we will see you in the next episode.